Okay, so today we are going to be analyzing the errors found in some clips, discussing the mathematical and conceptual errors, and how I would solve them, and I actually will be solving them to show you the answer that I got and the correct answer. All right, so in this first clip, there are four students running the big race. How many ways can the four runners place in the top three where order doesn't matter? So this where order doesn't matter is very important because before you even get into this video that we're going to see that they did wrong, you already know that we should be dealing with combinations. Order does not matter in combinations. If it does matter, we're working with permutations. However, order does not matter, therefore we're working with combinations. So in this video, the person tried to convert solve in permutations first, and then translate that into combinations. Um, However, you cannot go from permutations to combinations. That's not possible. Also, the way that they solved for permutations is incorrect. The way you would do it is 4p3, which would get you an answer of 24, not 64. Also, to convert to combinations, which is a lot more complicated than this, you can't just divide it by a number like 4 to get 16. So the way that you do solve it, they have it at the end with the 4c3. It does not equal 16 though. So what you do is you grab your calculator, you do 4, go to math, probability, C, and then 3, and this is going to get you your answer of 4 total ways. So the answer to this question is 4, not 16. Second one, you have a 90% chance of getting each question correct. What is the probability you will score at least 98% on the math test? So this again, you're going to be working with combinations because it doesn't matter the order of getting each question correct. You can get the first 90 right, and then you'll get the last 10 wrong, or you could get the first 10 wrong and the last 90 right. You're still going to get 90%. So we'll move on to the second video. And here, they were actually pretty close to getting the correct answer. They were just missing a second part of the equation. So when putting it all out, they did it right. You have the total number of outcomes on the left, combination, the the number of outcomes that you're looking for on the right. In this case, they had 98% correct on a 100 question quiz, which is 98 questions correct. So you can write 98. However, here is where they messed up. They did multiply it by the correct numbers. All of this is right. You multiply the chance of the outcome happening and put it to the power of how many times it happened. However, you have to do it for both ways. So you have to do the chance that you get it right, which they did here, and then multiply by the chance you did it wrong. So I'm going to go in my notebook now and let's get a blank page and work through how we should solve it. So all they were missing was the chance they had of getting it wrong, as well as multiplying it by the exponent of how many times it popped up. So to illustrate that, they had it correct in terms of 100 question test. So there's 100 total outcomes, time or combination, because we're working with combos because order does not matter. And then we're looking for what is the probability they get at least 98%. So when it says at least, that means you're looking for 98 questions percent, 99%, and 100%. And at the end, you're going to be adding up the percents you get. So 100 combination 98 times 0.9 to the power of 98, because that is the chance of getting it right, and that's the number of times you get it right, and then times 0.1, because that's the chance of getting it wrong, times the number that you get wrong, which is 2. Then you grab where did I put my calculator? Oh, right here. You grab your calculator, and you type this in, 100 combination 98 times 0.9 to the power of 98 times 0.1 to the power of 2, which you get 0.016, or converting that to a percent, 0.16%. Okay, so you just do the same thing for the others, combination, except for 99 outcomes. Then one time you get it wrong, go back to your calculator. Type it in. Power of 1. In this one, it says e negative 4, which means 10 to the negative 4th power. So just times that by 100 to get the percent. And you get 0.029. You can round that up with the 5 to 0.03. So 0.03% of that happening. And then 100, see 100, because you're getting them all right this time, 100 times 0.1 to the 0 or 0, which means you go 100, math ability C, 100 times 0.9 to the power of 100. And just for visual purposes, I can type in 0 to the 0th power, times that by 100, and you get this number right here, 0.0026 or 0.0027, just to round it off with that. Okay, so now what's the last step? You just add all these percents together. So that plus that plus that. I'll go to my calculator and type this all in. So 0.16 plus 0.03 plus 0.0027 equals 0.1927%. So therefore you have a 0.1927% chance of getting higher than a 98% on the test. All right, so that's pretty simple. Moving on to the last example, there are 6 crayons, 2 red, 1 orange, 1 yellow, 1 green, and 1 blue. How many ways can you arrange 4 crayons in order? So this one, order does matter because you're dealing with different colors, and it doesn't say that order doesn't matter. So you're dealing with permutations. In this final example, he tries to expand the permutation equation. However, this is not how you expand it. They wrote something like this, where 6 factorial, and expanded it out like that over 4 factorial. However, it's not as simple as that, 6 factorial over 4 factorial. To expand 6p4, I can write it out here, 6p4. So what they did wrong is they just expanded it out incorrectly, and because of that, they got an incorrect answer. There's a much simpler way to do it, where you just type 6 permutation 4 into the calculator. However, I can expand it out like he did just to show you what he did wrong. So 6p4, let's just solve this algebraically first. NPR. And to expand this, you get n factorial over n minus r factorial. And that's literally it. That's how you expand that. So to do that, you would do 6p4 like that equals 6 factorial over 6 minus 4 factorial, which equals 6 factorial over 2 factorial. If you expand that out like he did, 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1, 2, 1 cancel. And then you do 6 times 4 times 3 times 6 times 5 times 4 times 3 times. You will get 360 as your total answer. Another way you can do that is you go into your calculator, do 6 permutation 4, and just delete that, and you will end up with 360 as such. So some simple errors with even simpler fixes. And yeah, that's it. I hope you enjoyed.